All right, class. Welcome to the 5.1c lesson, more exponent properties. Okay, so now in 5.1b, we learned about what would happen if you multiplied like bases. And we knew that we added the exponent. When we divided like bases, we knew that we subtracted the exponents. So today we're going to learn about a special situation where you have kind of like a base with an exponent inside of a parentheses, and you ask yourself, what would happen if there was an exponent outside of that group, right? So let's take a look. So obviously you could try this on your own and try to figure out which of these six options would be the same as 2 to the third power to the fourth power. But I'm just going to remind you all that 2 to the third power with a 4 on the outside is basically saying, class, isn't that like saying 2 to the third times 2 to the third times 2 to the third times one last 2 to the third? Right? It's basically saying, hey, what's ever in that group, I want you to take that group and multiply it by itself 4 times, right? So then when you realize that they all still have the same base, the 3, and the 3's all can be added, and you end up with 2 to the 12th power. Now, I don't think that was really surprising to anyone, and you can already tell what is the special relationship when you have an exponent outside of a group. What should that exponent do with every exponent inside that group, right? Um, what does 2 to the third to the fourth power simplify to? So do you see 2 to the 12th anywhere? I see that in E. I'm not sure which of the other ones are, but one thing we do know is if there were really 12 twos, right? Like let's say I'm going to write down the twos like this. And 2 times 2 is 4, and 4 times 4 is 16. So each row is going to equal 16. And wait, doesn't that equal 16 cubed? Right? That is correct. So now what I'm going to do is I'm going to use my calculator and figure out what 16 cubed is. And it is 4,096. So I know that D is correct. And are there any other choices? 2 to the 7th is wrong. You could see that they added the exponent, which was the previous lesson. But that's not correct here. 6 to the 4th seems okay, but actually it doesn't even seem large enough to be 4,096, right? That's really 6 times 6 times 6 times 6, which is, and 36 times 36, which is, let's see what that is. It's 1296. That's actually kind of close. It's not close enough. And then finally, 4 to the 4th times 2 to the 4th. Unfortunately, there is no shortcut to this. What you should just do is just do 4 to the 4th power, which is 256, and then 2 to the 4th power, which is 16, and just kind of multiply them. And you end up with 4,096. Okay, so yeah, that works. Okay, so what can we conclude with our observations here, right? What can we conclude when we have a power raised to something that already has a power, right? To find the power of a power, multiply the exponents and keep the base the same. Okay, the algebraic rule for the power of a power states that x to the eighth a power with a b outside of that group is really x to the AB. Wish I wrote that B a little bit clearer. X to the AB. Okay. So let's do a little bit of comparing and contrasting with what we've learned in this module so far. It says complete the Venn diagram to explain the differences and similarities between x squared to the third power and x squared times x to the cube. Okay, so let's first talk about what they have in common, right? Both of these expressions do have x squared, right? Both expressions have x squared. But this one is kind of like the 5.1b lesson that we did. We know that we add the exponents, right? This is what we call a product of powers, where we add the exponents because they have the same base. And this one is called a power of a power, where we actually don't add the two exponents. In this case, we have to multiply the two exponents. So you get x to the sixth here, and then here you get x to the fifth. So it's really, really easy to mess this up. It's really, really easy to kind of mix these up together. But remember that if you see a parentheses, that 3 really just has to distribute to every power inside the group. Eventually, in the next few pages, we're going to see that if there's more than one term, like x, if there's like 3 terms inside the parentheses, that this 3 must distribute to every power inside that group, right? So the exponents are multiplied here. Okay, this is pretty much like, it's interesting because we're learning about kind of like the order of operations, but we're pretty much learning a new operation altogether, right? In our mathematical careers, you've learned how to add, subtract, multiply, and divide numbers. And now we're officially kind of introducing the idea of exponents. Okay. So because I wrote all over this, I'm going to use a different page to go over the next page. Number 5 says to simplify x to the third power with x to the fourth. Is it the same as x to the 3 to the fourth? Well, that's kind of weird. This is like an exponent that has its own power, right? No, they are not the same. X to the 3 to the fourth is actually x to the 12th power, whereas 3 to the fourth in general is 3 times 3 times 3 times 3, which we know is 9 times 9, which actually is, this is x to the 81 power, right? So it's really got to be really, really careful. These are not equivalent, right? So let's write that down. Not equivalent. Okay, so again, I think 6 through 11, if we were in class, I would say go ahead, class, and take your time, practice these problems on your own. I don't think you really need to hear much more instruction at this point. So if you want to press pause, you can. And I'm going to go ahead and just discuss the answers, right? So a cubed with the 5 outside, we multiply. This is a to the 15th, right? Take your time with something like number 7. C to the 5th power with a 6 on the outside would be C30. And then C30 with a 7 on the outside is kind of like this, right? Which is C210. Well, that's a big number. It really depends on how big the base is, though, right? It looks really, really big because the power is 210, and for sure it is. But if C is not even a big number, like if C is a decimal, then this won't be as big. And in fact, it'll be really, really small. Okay. X to the n with a 2 is just x to the 2n. Okay, number 9 is interesting because the power of A on the inside is an expression. So just like we've been working with distributing, we have to distribute this power 2 to every part of that expression. So this ends up being a to the 2n plus 2. Okay. It's no different than saying, hey, what is n plus 1 times 2 on the outside? Okay. So here we have bn to the third power. So that's going to be b3n. And then what's interesting is we then get a little bit of 5.1b, right? So this is where you would just add the two powers together, and you can combine 3n with n, and this ends up being b to the 4n plus 1. Okay, so you can see how math continues to expand on our previous knowledge. Something like number 11 seems a little bit intimidating right now, but I'm not going to be scared. You end up getting r to the 2n plus 2 times r to the n minus 2. Okay, and we're happy when we see this, class, because when you have r and r, you know that, and you're multiplying, you know that all I have to do is combine these two expressions and set them and raise them to r. So 2n with n is 3n, and then 2 and negative 2 is 0. So I'm done. Okay, let's take a look at number 12. It says, what does 4a cubed squared simplify to? Okay, so I'm going to expand it one more time just for us to reiterate how important it is. This expands to 4a cubed times 4a cubed, right? Because it's like whatever is in that group, you're squaring it, you're telling that group to multiply itself twice. So that's 4 times 4 is 16. 16 with a cubed and a cubed is 16a6. Okay, that's the expanded way to do it. I'm going to go ahead and show you another way to do it as well. Okay, so if I have 4a cubed squared, the first thing we have to remember, class, is very, very important, is the 4 actually has an invisible 1. Right? Every number in the past, when we write them as a number or a variable, they always had a degree. It's just we never really had to write it, because if we don't write the degree, it's understood that the degree is 1. Okay. So with a 2 on the outside of that group, the 2 is then asked to distribute to every degree. And by distributing, it has to multiply every degree inside the group. Okay, so this ends up being 4 squared a6. And then 4 squared is unacceptable because we know that 4 squared is a known value. It's basically like saying this is not the final version, and we know that 4 squared is 16, and 16a6 is the final answer. Okay, so again, when you have a power, you must distribute it to every degree or power inside the group, even if it doesn't have one, because even if it doesn't have one, there's an invisible 1. Okay, so let's write that down. To find the power of a product, distribute the power outside of the group to every degree or power inside the group. And when I say distribute, that basically means you have to multiply it, right? You have to multiply the degree outside with every degree on the inside. Okay, so basically, let me give you an example. Let's say I have a, b, c to the x power, right? That's going to equal ax, bx, and cx. Okay, seems pretty easy, right? Seems easy enough. Just like everything in math class, you definitely want to practice. You want to give yourself an ample enough of practice. And yeah, let's go ahead and move on to page 16. Again, I think 15 through 20 is an excellent opportunity for you to practice. I'm going to go over maybe 3 of these problems. Uh, I think you should definitely do all of them just to practice. But let's go over something that like number 18. Notice how there's 4 terms on the inside of this group, and really, like I said in the previous page, if you have a degree that's not there, there's an invisible 1. So this 4 has to distribute to the 2, to this 2, to that 1, and then to that 2. So it has to distribute 4 times. And even though that looks really challenging, it's not, right? So this ends up being 3 to the 8th, x to the 8th, y to the 4th, z to the 8th. Okay. But the thing is, what is 3 to the 8th power? So that's the part where you have to use a calculator, right? 3 raised to the 8th power is 6561 x8 y4 z8. Okay. Ooh, okay. So number 19 and number 20 are definitely challenging. They're the challenge problems of this page. They look intimidating because there's a negative. So I'm going to go ahead and give you a little bit of a brain teaser. And I'm going to ask, you know, if this was a negative x, let's say, and I had a 10 on the outside of that, what would the final answer be? Would it be a positive number or would it be a negative number? Right? The fact that this is an even number is a giveaway that tells you that the final answer of this will be positive, right? Because you can see how there's going to be an even amount of negatives, right? So therefore, even amount of negatives. And this is what we call an even function, which will lead to a positive answer. Okay. And then if it's a positive answer with a 3 on the outside, well, then that will be a positive answer as well. So when you know that, you don't have to be intimidated by the negative sign. You know that this is just going to be d to the 20, and then with a 3, which ends up being d to the 60. Again, it all boils down to your understanding of if that's a negative, right? And I you can totally ignore the square, right? The square doesn't even matter because you're just assuming that the entire group is negative. And if the entire group is negative, then when you raise it to the 10th power, it's going to be positive again, right? So then once you know that, you can almost go like that and just ignore the negative, because you have a good understanding of what the sign will be. So using that knowledge, wow, look at number 20, right? 20, I'm going to use that same principle. The inside is a negative, but then it on the outside, it's raised to the 3rd power, right? So because this is an odd function, this is going to have a negative result. And then once you raise that to the 5th power, it's still going to be an odd function, which means basically, class, your final answer has to have that negative sign. Your final answer, that negative sign will not go away because even though you have A3 and B4, this 3 is going to make it negative again. And then the 5 is going to continue to perpetuate the negative sign. So I can definitely explain this more in person, but it's just important for you to realize that before you try to like distribute the 3 and distribute the 5. Okay. Your final answer will be negative, and then you end up getting negative a to the 9th, b to the 12th, then with a 5 on the outside. And when you have a 5 on the outside, your final answer will therefore be a negative a to the 45, b to the 60, because all we're doing is distributing. Okay, there's a 1 here, or there's a 1 here, invisible 1, that you could distribute to. But when you distribute a 5 to the 1 power, it's just going to be negative 1 to the 5th, which is negative. Okay, now let's move on to something like 21 through 24. Realizing this is a pretty long lesson, so I'm just going to make a long video, and maybe we'll cut it up and have you watch it in multiple sections. But 21 through 24 says, use exponent properties to solve for x. Show all of your work. 5 to the 6th power equals 25 to what power? Okay, so this is where you would probably want to change the 25 to something in terms of 5. Notice how it's not a coincidence, class, that 5 and 25 were used. 5 to the 6 is obviously 5 to the 6, but if I wanted to write 25 as 5 squared, wouldn't that be acceptable? And then raise that to the x, right? You could see what I did. 25 is literally 5 squared. I didn't change the overall value. All I did was I changed the way we looked at 25 to the x power. And this is going to equal 5 to the 2x. So if I said 5 to the 6th is equal to 5 to the 2x, then doesn't that mean that the exponents can be compared to each other? Right? So then you get 2x is equal to 6. And your final answer, x equals 3. Okay, this is something that you will need to be more familiar with. Again, always take the larger number and ask yourself, how do I make this base become a more prime, more a base that can be compared with this 2? You obviously can't change the 2 to an 8, but you can go backwards. You can go from a large number back to a prime factorization style, I guess, or version of it. So when we see 2 to the x, I want to compare it to 8. So I know that 8 is actually 2 cubed. And then I go like that, right? Because it's 8 squared. So this is 8. 2 cubed is 8, and 8 squared. So this is 2 to the x is equal to 2 to the 6. Remember, we're multiplying these, and this is a really, really important skill. So you need to practice this. If I am moving a little bit too fast, please go back and pay attention and study what I did. Obviously, you just have to be familiar with how to convert the larger number to the same base. Okay. Let's see if there's any more that I can do from page 17, maybe one more problem. I do think that we should probably use this to study and use this to practice. 25, using your knowledge of exponent properties, simplify x to the 5th and explain x to the 5th squared. Okay, so when we see a power outside of a group, we know that all we really have to do is distribute the power, right? Again, like I said, every term has a degree. It's just not there, right? There's a 1 here, there's a 1 there. All you have to do is distribute the 2 to each degree. And your final answer here is going to be, well, not your final answer, but you would get x squared over 5 squared. And then you have to calculate 5 squared, which is x squared over 25. Right. Throughout our entire experience with something outside of a parentheses, we know that distributing is kind of implied or expected, right? The algebraic rule for the power of a quotient is going to be a over b to the x power is a to the x over b to the x. Okay, so let's try one last problem, number 30, just because it looks intimidating, but it's really not. One thing I like to do, and I always recommend, before we even try to distribute this 5, because you can see that 5 is outside of the parentheses class, I would just simplify. So here's my tip. Always simplify your group first before distributing the power. Right? This will save you a lot of time, and it will save you the headache of, ridiculously large numbers. So I'm going to totally ignore the 5 and just simplify what's inside there. Right? So I get 3 times 2, which is 6. A5, A4 is A9. Then I have over 4A10. Okay? So one thing we cannot forget, class, is the 6 divided by 4 is still, it's kind of like 6 over 4. So that's 3 over 2. And then A9 divided by A10. Well, that's like saying there are 9 A's on the top. There's 9 A's, and then there's 10 A's on the bottom. Well, if they were to compete and they were to cancel each other out as much as possible, which side would win? Would the numerator win, or would the denominator win? You can see that the denominator has one extra A. And for this reason, there's only one A, and it's left on the bottom. That's how you simplify A to the 9th divided by A to the 10th. You see which side has more, and the side that it has more, the remaining will be left over, right? Just a quick recap. A to the 9th over A to the 10th is equal to A to the negative 1, which you could see is 1 over A. Now, we're going to talk about this in a later lesson, so I just want to give you a little bit of a preview of negative exponents. Okay, so now we then can finally distribute that 5. That 5 has been patiently waiting. Hey, can I distribute, please? And you're like, no, hold on, let me simplify first. And then you end up getting 3 to the 5th, 2 to the 5th, A to the 5th. Okay, you can see how I'm totally commanding the space of this page, just so you can see. Now, let's go ahead and use, what is 3 to the 5th? You have to calculate that, and then you have to calculate 2 to the 5th. 3 to the 5th, I believe, is 243, right? Because it's 81 times 3, which is 243. 2 to the 5th is, 4 times 4 times 2, which is 32, and this is A5. All of this work was to show for number 30. Okay, I hope you learned a lot by watching this video. This video did not include all of the problems. Obviously, there is a lot of extra work that you can do to practice. Please review this video to help you with the quiz and the test. I hope you enjoyed, and see you in class. Thanks for watching.